Okay, I'm going to take a few minutes to try to go over some of the problems on 41 through 50. We went over most of these in class today. For those who were not here or who need a little extra review, I'm going to try to explain it. So in 41, they have a problem where they give you a function. You're throwing a ball up at an initial velocity of 20 feet per second from a height of 6 feet. So that's where the 20 and the 6 come from. The negative 16 has to do with gravity. And they want you to figure out when will this ball reach its maximum height. So to do that, we're talking about the vertex. Where's the high point on this graph? So to find it, the x value will be negative b over 2a. So that's negative 20 over 2 times negative 16, which is negative 20 divided by negative 32, which is 0.625. So after 0.625 seconds, this ball will be at its maximum height. And then to find out what that actual height is, you plug in 0.625 everywhere there's a t, here and here. And when you do the math for that, you get 12.25. So the maximum height of this ball is going to be 12.25 feet. That happens at 0.625 seconds. And then number 42 and 43 and 44 are all worked exactly the same way. They just have a different initial velocity and a different starting height. So follow the example back here on 41, and you should be able to do 42 and 43 and 44. Problem 45, they give you a piece of paper that you're going to fold up, and it's this 10 by 18 piece of paper to start with. So this side's 10, this side's 18, and they want you to fold it up so that it's U-shaped, and I know I can't draw that, but it ends up going something like this. We still have this piece of paper back here. So it's folded up, and we'll try to draw it. Okay, so we folded it up. This was 10, this was 18 before we folded it. So if I fold it and the height of this is x, then this side would be 18 minus 2x because I fold x off of each side. And the volume of a rectangular solid is length, which in this case is going to be 10, times width, which is 18 minus 2x, times height, which is x, and that's your volume. And what you want to find is where is this maximum volume happening? Where are we getting the most volume? For what dimensions will we get that? So if volume equals length times width times height, and I distribute that, I find out the equation that represents this is negative 20x squared plus 180x. So to find that maximum height, I get x equals negative b over 2a. So that's negative 180 over 2 times negative 20, which is negative 180 over negative 40. And I'm going to get a calculator to help me with this because I'm going to have to plug it in here in a second. So negative 80 divided by negative 40 is 4.5. I think 4.5. I'll verify it here in just a second. All right, so negative 180 divided by negative 40 is 4.5. So that's going to be the x value that's going to get you the highest volume. So what would that make the dimensions of this box be? If x is equal to 4.5 gives me that the highest volume. And I'll look at what the volume is going to be in a second. But when they ask for the dimensions are 10 by 18 minus 2x times by x. And if x is 4.5, then my dimensions are going to be 10 by 18 minus 2 times 4.5. That will be 9 times the height is x, so that'd be 4.5. That's the dimensions that give you the highest volume. And to figure out what that volume is, if your question asks that, you just take your calculator and multiply 10 times 9 times 4.5. 10 times 9 times 4.5. And you get 405 is the biggest volume that you could get for a 10 by 18 piece of paper. All right, 46. You've got 32 feet to build a rectangular garden. You're not going to build it against this wall. This wall is going to be open or against school. So you only have to put the fencing on the 3 sides. So if this side is x, then this side would be x, and this side would be 32 minus 2x. So my equation is x times 32 minus 2x, which would be, if I distribute, 32x minus 2x squared. So a is negative 2 and b is 32, and you got to find the vertex. The x value would be negative b over 2a, and then you plug that in to find the y value. 47 and 48 and 49 and 50. I've kind of got set up here to help you out. 47, they tell you you've got 20, the base and the height add up to 20. So I made the height x and the base 20 minus x, and it's a triangle. So the area is 1/2 base times height. So 1/2 times the height times the base, and then you would just have to distribute, oops, sorry. So let's see, 1/2 times 20x minus x squared, if I distribute x times 20 and x times x. So that would be 10x minus 1/2 x squared. So here's your a, here's your b, and you can solve it. In 48, it's parallelogram, so it's base times height, and they tell you that the base and the height add up to 69. So if the base is x, the height would be 69 minus x. So it's here, and you distribute, and then you can find the vertex of this parabola. In 49, they give you the equation, so you just have to use that equation to find your minimum point. I think they want to minimize the average cost. The only thing, my only recommendation in 49 is that they give you your answer in hundreds. Meaning if you find your answer is x equals 3, that means it was 300 shares you needed to make. And then in problem number 50, it's the revenue minus the cost. This is the revenue, 5x. This is the cost, and you're subtracting all of it. And when you do that, this is the equation that you get. Negative 0.001x squared plus 3.8x minus 60, and you just find the vertex of that. Hope that gives you a little help on 41 through 50. Good luck, and we'll start 3.4 tomorrow.